Welcome back to the Learning Studio. You're watching our mathematics series in the section on data, algorithms, and computation, where we uncover the math powering AI, algorithms, and the digital age. If this is your first time here, don't forget to follow us by clicking the link below. And remember, the full playlist is in the description, so you can enjoy every episode in sequence. Today, we're diving into Bayesian Mathematics, the framework that allows machines and humans alike to learn, reason, and make decisions when faced with uncertainty. Imagine you're a doctor diagnosing a patient. You don't know everything up front. You start with a prior belief, then update it as test results come in. That's Bayesian thinking. Or imagine an AI system predicting tomorrow's weather. It doesn't give a yes or no answer. Instead, it provides probabilities, reflecting the uncertainty in the data. This way of reasoning isn't just practical, it's mathematical, and it's known as Bayesian mathematics. Core concepts explained simply. Here are the essentials. Bayes Theorem. At its heart, Bayesian math is about updating beliefs. Prior knowledge plus new evidence equals updated, posterior belief. Probabilistic programming. This is where we build models that incorporate randomness directly, allowing machines to simulate uncertainty and reason more flexibly. Uncertainty quantification. Instead of a single prediction, Bayesian methods provide confidence levels, crucial in safety-critical AI applications like medicine or autonomous driving. Learning from data. Bayesian inference lets models adapt continuously as more data arrives, making it a natural fit for online learning and real-world systems. Why it matters in AI, computing, and technology. Bayesian mathematics is a cornerstone of modern AI. In machine learning, Bayesian methods power algorithms that handle small data, noisy data, and uncertain data. In probabilistic programming, tools like PyMC, Stan, or Pyro allow researchers to model complex uncertainty directly. In robotics, Bayesian filtering, like the famous Kalman filter, helps machines localize and navigate the world. In decision-making systems, Bayesian reasoning ensures predictions aren't just answers, but informed answers with measurable confidence. It's what allows AI to say not just what it thinks, but how sure it is. So Bayesian mathematics is the art of reasoning under uncertainty, turning incomplete information into smart, adaptive decision-making. It's the bridge between raw data and intelligent action. In our next episode, we'll explore approximation theory, the mathematics that explains how neural networks can approximate complex functions and why they are so expressive. Don't forget to follow us by clicking the link below and check out the full playlist in the description. Each episode takes us one step closer to mastering the math that powers intelligence itself.